The world is changing fast, but you can learn it at a slower pace.
Special English.
Please note that the following stories are read by AI, but all information has been written and verified by professional editors. You are listening to Special English. Chinese scientists have developed a programmable quantum computing prototype called Jiuzhang 4.0 that has set a new world record for optical quantum information technology. The study has been published in the journal Nature, led by the University of Science and Technology of China. The team used the prototype to solve the Gaussian boson sampling problem at a speed more than 10 to the 54th times that of the world's most powerful supercomputer. The researchers said they manipulated and detected quantum states of up to 3,050 photons, a significant leap from the 255 photons achieved with the previous Jiuzhang 3.0. Current mainstream quantum computing technological routes include superconducting, ion trap, photonic, and neutral atom systems. The Jiuzhang series of prototypes encodes quantum bits using photons and performs quantum computation through the manipulation and measurement of these photons. Since its successful construction in 2020, the series has undergone several upgrades, achieving quantum computational advantage and repeatedly setting world records. Lu Chaoyang, a professor at the University of Science and Technology, said, "The research team developed a high-efficiency optical parametric oscillator light source and a spatiotemporally hybrid-coded interferometer." According to Lu, by integrating 1024 high-efficiency squeezed-state optical fields into an 8,176 mode spatiotemporally hybrid-coded circuit, the team was able to manipulate and detect up to 3,050 photons. This means that the most complex data sample generated by Jiuzhang 4.0 takes only 25 microseconds to produce, shorter than the blink of an eye. In contrast, the world's most powerful supercomputer would require more than 10 to the 42nd years to calculate the same result. Lu noted that the results from Jiuzhang 4.0 represent a major leap in the scale and complexity of low-loss photonic quantum processors, offering new possibilities for constructing trillion-qubit mode three-dimensional cluster states and future fault-tolerant optical quantum computing hardware. You are listening to Special English. The Civil Aviation Administration of China has established a low-altitude safety department as the country steps up efforts to foster the low-altitude economy. The new department is responsible for formulating development plans for low-altitude civil aviation, coordinating low-altitude safety and development, and building low-altitude flight service dispatch platforms and flight service station systems. The move came as China has intensified efforts to tap the low-altitude economy, which refers to the economic activities and industries centered around manned and unmanned aerial vehicles operating in the airspace, usually within 1,000 meters above the ground. In December 2024, China's National Development and Reform Commission established a department dedicated to the low-altitude economy to formulate and organize the implementation of strategic, as well as mid-term and long-term development plans, provide policy recommendations, and coordinate major issues related to the sector. According to the Civil Aviation Administration of China, the country's low-altitude economy has seen rapid growth in recent years. Its market size is expected to exceed 3.5 trillion yuan, about 511 billion US dollars, by 2035. China has launched a pilot program for artificial intelligence ethics review and services. That is according to a notice issued by the Ministry of Industry and Information Technology. The pilot program will first be carried out in provincial-level regions that are home to national pilot zones for AI industrial innovation and application in a bid to explore practical approaches to implementing AI ethics review and service mechanisms. The move comes as ethical risks in AI, including algorithmic discrimination and emotional dependence, have become increasingly prominent, underscoring the need to establish such mechanisms. Key tasks of the program include refining provincial-level AI sci-tech ethics review rules, guiding the establishment of sci-tech ethics committees, exploring the building of ethics review and service centers, as well as carrying out AI ethics review practices, turning review experience into technical standards, and improving ethics review reporting mechanisms. The notice calls for establishing a national AI ethics risk monitoring service network, compiling related training materials, offering regular ethics courses and providing ethics risk monitoring and early warning services to support pilot cities. That is the end of today's program. I hope you will join us every day to learn English at a slower pace.